In this lecture, we evaluate the limit 10x upon x whole to the power 1 by x square when extending to 0. If you put extending to 0 here, 0 is, uh, we know that our limit of 10x upon x when extending to 0 is nothing but 1. Its value is 1 to the power, if you put x is 0 here, 1 upon 0 is infinity. It is the form of 1 to the power infinity. And we know that if any limit has the form 1 to the power infinity, and if you want to evaluate it, we have to first take log on both the sides. Let us take log on both the sides. We have log L is equal to limit of 1 upon this multiplied with the log of 10x upon x, 1 upon x square into log 10x upon x, because we know that log of m to the power n is n log m. Now, if we put the limit once again over here, 1 upon 0 is infinity, and its value is 1, log 1 is 0, it has the form infinity into 0 form. Again, we know that if you want to evaluate it, uh, we are not able to simplify, or we are not able to apply L'Hospital rule if it has the form infinity into 0 form. If we want to apply L'Hospital rule, either this should be converted into infinity by infinity form or 0 by 0 form. So let us try to do like that. Let me write down log 10x upon x in the numerator and x square in the denominator. Now we know that uh, when extending to 0, 10x upon x is 1, so log 1 is 0. And similarly, if you put x is 0 over here, it is again 0, so it is 0 by 0 form. Now we can apply the L'Hospital rule. Now, if we want to find out the derivative of log x, it is nothing but 1 upon x. We can write down 1 upon x means 1 upon 10x upon x. It can be written as x upon 10x. Again, if you want to find out the derivative of 10x upon x, we have to use the u by v rule. What is that? It is denominator, derivative of numerator, denominator, derivative of 10x is sec square x minus derivative of denominator, derivative of x is 1, and into numerator means 10x, the whole divided by denominator square means x square, and again derivative of x square is nothing but 2x. Let me again explain it. We want to find out the derivative of log of 10x upon x. Here derivative of log x is 1 upon x, so 1 upon 10x upon x, and if we write down in correct form, the x will goes to numerator and 10x will be in denominator, multiplied by derivative of u by v. So derivative of u by v is denominator, derivative of 10x is sec square x minus derivative of denominator, derivative of x is 1 into numerator whole divided by denominator square. This is the derivative of log 10x upon x. And again, derivative of x square is nothing but 2x. Let us simplify it. Now, 1x will cancel. 1x will cancel over here. 10x, 10x, 1 upon 10x into x sec square x minus 10x upon x and whole divided by x. So now, this x will come down, x sec square x minus 10x, and we have to multiply this by x 10x. Write down x 10x is nothing but limit when extending to 0, x 10x is not, we are not cancelling over here. Limit of x 10x when extending to 0 is nothing but 1, and now this x square and x will become x cube. So in the numerator, x sec square x minus 10x upon x cube. If we substitute the limit, it is nothing but 0 by 0 form, because sec 0 is 1 and this is 0, 0 into 1 is 0, 10 0 is 0, and upon 0. So it is 0 by 0 form. If it is 0 by 0 form, we again apply L'Hospital rule, derivative of numerator, x, first function, derivative of sec square x is 2 sec x. Again, derivative of sec x is sec x into tan x, plus derivative of x is 1 into sec square x, minus derivative of tan x is nothing but sec square x, and whole divided by derivative of x cube is 3x square. Now this plus sec square x minus sec square x will cancel. 1x will again cancel over here. Now we have 2 upon 3, and this 1 by 2 is pending over here. So we should write down also 1 by 2. There is a 1 by 2 over here. So 2 upon 3 into again 1 by 2 limit x sec square x sec square x into tan x upon x square. 1 by 3, this 2 will cancel. Sec square x into tan x, because 1x will cancel. Again 10x upon x, when x tending to 0 is nothing but 1. This is 1. And if you put x tending to 0 here, sec 0 is 1. So this is 1 and this is 1. So 1 by 3 into 1 into 1, the answer is 1 by 3. Hence the value of L, because this is the value of log L is 1 upon 3. If we take antilog on both the sides, L is equal to e to the power 1 by 3. Therefore, the given limit has the value e to the power 1 by 3. This is the desired result of the given limit. Thank you.